Okay, so today I'm going to start with files a little bit so that you can at least do your homework, and then we'll go over it a little bit again on Tuesday. There is a quiz next Thursday on loops, everything having to do with loops. So hopefully you've started your homework. I also have a bunch of exercises. We'll do some of those today and Tuesday, okay? So all the I/O, or input-output, that we've done up until now is from the keyboard, okay? And we call this interactive input-output because basically the keyboard responds, you answer, and in this case, whenever we do input and output from the keyboard, we have to ask the user, and we must be somewhat user-friendly, and that has a little bit of an overhead associated with that. We also talked about using echo checking, and who can tell me what echo checking is? I forget. What's echo checking? Jared? We repeat the user's input so that it sort of avoids that calculator effect that you just get an answer. So echo checking is a simple way to tell the user what they entered, because input error can be a big problem. And you saw that yesterday in the lab with the input validation, okay? How this is a huge source of problems, both security-related and robustness-related, that all input is a source of potential harm. And this is why we did this focused lab yesterday, where we talked about the importance of validating your input. We also saw the challenges of validating your input, because you can get very, you can spend a lot of time doing that, and I know that has a lot of overhead with the code. Okay, so another way of doing input-output, let me get to the right screen, is to use what we call batch processing. And basically, this means get data from a file. And this is actually extensively used. Because if you think about it, many times our input comes from another source. It could be another device. It could be another program. So while many programs have some input that comes from the screen, there's a great deal of input that comes from a file, and also output as well. So rather than just displaying to the screen and doing that ugly copy and paste that we do, which is not practical, perhaps we would like the data to go to a file, and we could then print that or edit that at our leisure, okay? So file is a very convenient way to interface with a program, okay? Now, the good news is that most languages do their input and output from the screen very much like they do it from a file, because we would consider the keyboard. The keyboard would be considered the standard input device, and if we want to change that to a file, it's not that difficult. So a lot of things are going to look similar. So there is some overhead associated with using files, and one of the reasons I don't spend a large amount of time talking about this is because it's very language specific. So there's some details associated with opening files and setting handles to files that vary greatly from C++ to Java to Python, etc. So I really want to talk more conceptually about files, although we will do a lab where we open a file and we write to a file. Question? Well, yeah, so in other words, we're going to use the simplest, which is basically where you can just read from a file and write to a file, and you can't write to the middle of a file. There's several different processes that are more complex. We're going to sort of take a look at the most simple. But again, that still has some overhead. So, and the overhead is very language specific. That's why I don't like to spend a lot of time talking about it, because next semester you all will be using Java, okay? So we will do a lab. I'll show you all the steps. But what I really want you to zero in on is the concepts of reading from a file, not the specifics in the actual language. Does that make sense? Okay. So the advantages to using files are many. We've talked about the issue of trying to sit at a keyboard and enter thousands of pieces of data. This can be really annoying. And if you make a mistake, how do you correct that? If you're typing a lot of data. So if you enter it into a file, you can take your time. You can close the file. You can edit the file if you're leaving or made a mistake. And so the file is a very, much more user-friendly way of entering large amounts of data. The other thing is, you've noticed with some of these programs, you have to enter a lot of data, and that's annoying every time you want to rerun. If we put it all in a file, when we want to rerun it, it takes, less than a second. Okay? So it's convenience once you've got the file created. The same thing holds true for output. Well, you've all certainly seen how annoying it is to copy and paste those output screens, and that's not the way that most programs work. That's really just in an educational environment. Okay? So if we want to have output go someplace that we care about and have a report, we most likely want that to go to a file. Does that make sense? Because we're not going to be copying, edit, mark, edit, copy, that stupid output screen. That's just something we're doing, for a temporary kind of fix here. So oftentimes we want our output to go to another file. And remember the final reason, which is many programs interface with each other. So let's say that I write a program where I'm collecting temperatures. Okay? And somebody else has a program where they analyze those temperatures and look at trends and et cetera, et cetera. So if I put my data into a file, then the second program can just read that file, right? So it allows interaction between multiple programs, which is a common thing to do.